So, PowerPulse is a home energy monitoring system that gives homeowners real time insights into their energy consumption. We were able to finalize the circuit design and we've successfully coded the device to connect to Wi Fi, which allows it to transmit data to the cloud. So, essentially, this means that users can now see their energy usage on the LCD screen while also storing data for easy access. With these improvements, it ensures stable operation and makes real time monitoring more efficient. Okay, so I'll
Right.
just go from this one. So we currently have two builds, one for testing and one for production, that are designed to measure and display data in real time. So we've made some modifications to our circuit design, transitioning to a fully digital system. Our devices now securely connect to Wi-Fi and transmit data to the AWS cloud, ensuring reliable data storage and accessibility. So we've also been able to add some hardware improvements and started developing the app's GUI. So far everything is on track for completion as scheduled.
So here we have a model of our circuit design. We have the ESP32 supplying the 5 volts to the display. We also send 3 volts to the sensor circuit. And then the sensor sends the signal to the GPIO to the display. And our sensor now can handle 230 volts.
All right. So for our embedded software development, we used Platform IO. It's an IDE extension of VS Code written by Microsoft. And the code language that we're using is C++. So this program allows us to test and upload the code to the ESP32 device, where we are able to access and secure the Wi-Fi module and transmit using the MQTT protocol to the AWS environment. So the way the code works is it takes a measurement every 2.5 minutes, stores it in an array, and once that array fills up, it sends that data to the cloud. Okay, so this is our theoretical cloud architecture. We're using AWS. uh, just because it's the most widely used and there's a lot of documentation for it. So the sensor sends the data to the IoT rule environment and it downloads it to the DynamoDB database, which stores the data in a JSON document form. And that data is offloaded into an S3 bucket to save on costs. And now we are in the process of building an API for the app that we have. And this is just a first look at our app. We have a title screen to sign up function. We are using AWS's Cognito for authentication. So that includes sign up, forgot password, and all that good stuff. And we are building in React Native. It is a cross-platform mobile development framework that is developed by Meta. And we're going to use the API gateway to pull the JSON data in and display some graphical statistics.
Okay, and on this part, we have our Gantt chart. From our last progress report, we were behind with a few setbacks that we have, but now we have everything coming back on track. And then the contributions, we had Chris working on the hardware and developing the code. We had Antonella with the theoretical design and the analysis, and I worked on the abstract and the circuit analysis.
All right, so this right here is our production circuit board. As you can see, we have soldered the components onto a PCB board. And over here is how the display looks. We have milliamps and it uploads it to our cloud environment over here. This is the DynamoDB database. And here is a first look at our app. Right now, we just have the authentication that we are currently working on to complete. It's going to have the create account, sign up, forgot password, and email authentication so that it can be secure for the people that choose to use it. And once you get past the authentication screen, we will be displaying analytics in a graphical user interface. And this is our demonstration.